So this is going to directly reflect your test. Like I said, 12 questions, only doing specific ones. We're going to start with 109. So 109, you have 2 minus 3i times negative 5 plus 5i. You're just going to FOIL this out, combine like terms. So when you FOIL it out, you're going to do 2 times negative 5, which is negative 10. Then 2 times 5i is positive 10i. Then the negative 3i times 5, or negative 5, is a positive 15i. And negative 3i times positive 5i is a negative 15i squared. So we're going to combine our like terms and simplify that I squared. So this is going to give us negative 10 plus 25i minus 15 times negative 1. Remember, I squared is always turning into negative 1. From here, that negative 15 times negative 1 gives you a positive 15, so that's negative 10 plus 25i plus 15. You now have like terms with your negative 10 and your 15, so that leaves you with 5 plus 25i. We check to make sure that it's in the a plus bi form, which it is, so that's our answer. For 111, you have 2 plus I plus 5 minus 4i. There's addition between those two sets of parentheses, so we can just rewrite this without the parentheses and combine like terms. So we'll have 2 plus I plus 5 minus 4i. If we start with our constant, the 2 and the 5 are like terms, so you can combine them to get 7. Then you go to the I terms, those complex numbers, to get I minus 4i, which is negative 3i. We double check, make sure it's in a plus bi form. It is, so that is your answer. Next, we'll look at number 113. So 113 gives us 1 minus I minus 2 minus 3i. We have to distribute this negative into the second set of parentheses first. So when we do that, we're going to change the sign on each of those two terms. So we have 1 minus I minus 2 plus 3i. From here, combine your like terms. Start with the 1 and the negative 2. 1 minus 2 is negative 1. Then move to the negative I and the 3i, which gives you a positive 2i. It's in a plus bi form, so that is your answer. The next question we're going to look at is number 120. For 120, it gives us 3 plus I over 2 minus 3i. In order to rationalize that denominator, you have to find the conjugate of your denominator, then multiply the top and the bottom by it. So the bottom gives us 2 minus 3i. The conjugate of that is 2 plus 3i. We'll put parentheses around both the top and the bottom and just multiply 2 plus 3i by both. Up top, you're going to want to FOIL. So the 3 times 2 gives us 6. The 3 times 3i is 9i. I times 2 is 2i. And I times 3i is 3i squared. On the bottom, you have a difference of squares, so you can take that 2 squared minus the 3i squared. Up top, combine your like terms, change that I squared into a negative 1. So that's going to give you 6 plus 11i plus 3 times negative 1. On the bottom, the 2 squared is 4. The 3i squared is 9i squared. From here, the 3 times negative 1 is negative 3. So that's 6 plus 11i minus 3. On the bottom, that I squared on that 9 is negative 1. So we have 4 minus 9 times negative 1. Up top, combine your like terms. 6 minus 3 is 3 plus 11i. On the bottom, the negative 1 times the negative 9 turns into a positive. So 4 plus 9 gives us 13. At this point, if you could simplify, you would, but in order to simplify, the 3, the 11, and the 13 would all have to share a common factor other than 1. In this case, it does not, so that is your answer. Next, we're going to look at number 121. For 121, we are given parentheses negative 2i, close parentheses, to the fourth power. This power of 4 goes to both the negative 2 and the I. So that negative 2 to the fourth power is going to be a positive 16. And that I to the fourth power is I to the fourth power. You need to simplify this I to the power of 4. Remember, with these, you are using that chart where you have 0, 0.25, 0.5, and 0.75, where the 0 is just 1, then 0.5 is negative 1, the 0.25 is I, and the 0.75 is negative I. If we divide the power by 4, it gives us 1 with a remainder of 0. So that I to the fourth power is just 1. So we do 16 times 1, which is 16. We're also going to look at number 123, which also is going to use this chart. 123 gives us I to the power of 14. Now this one doesn't have a coefficient in front of the I, so you just have to worry about the I to the power of 14. Just like the other one, we're going to divide that power by 4. That 14 divided by 4 gives us 3 with a remainder of 2. So that's 3.5. So that I to the power of 14 is just negative 1. The next one we're going to look at is number 11, which gives us x minus 1 squared is equal to 9. We're solving this using that even root property. So what that means is we're going to take the square root, or whatever root of the power that we have there. So in this case, it's the power of 2, so we'll take the square root of both sides. Remember, when you take the square root, the fourth root, the sixth root, the even root of both sides of an equation, that plus or minus has to go in front of your answer for the root that you're taking of that whole number. So this gives us x minus 1 is equal to plus or minus 3. Because this separates, because this simplifies to be positive or negative 3, bless you, we're going to separate this into two equations. So we're going to have one that's x minus 1 is equal to negative 3, and one that's x minus 1 is equal to positive 3. And we're just going to solve both of them. So we're going to move the 1 over, adding it to both sides, and this gives us that x is equal to negative 2, and x is equal to 4. For number 17, which is the next one we're going to look at, we are solving by completing the square. We're given x squared minus 6x plus 8 is equal to 0. Your rule when you're completing the square is you want your a and your b term to be on one side and your constant to be on the other side. So we're going to move this 8 over first by subtracting it from both sides. This gives us x squared minus 6x is equal to negative 8. To find our new c term to make the left side a perfect square trinomial, we are going to use b over 2 squared. Our b term is that negative 6. Negative 6 over 2 is 3. 3 squared, negative 3. Negative 3 squared is 9. So we're going to add the 9 now to both sides of that equal sign. So that's going to give us x squared minus 6x plus 9, which is a perfect square, is equal to negative 8 plus 9. If we factor the left side, it gives us x minus 3 to the second power. If we add the right side, that's just positive 1. So we're going to take the square root of both sides here to give us x minus 3 is equal to plus or minus 1. Because this simplified to be 1 and negative 1, we're going to separate it into two equations and solve for both. So we're going to have x minus 3 is equal to negative 1, and x minus 3 is equal to positive 1. Move your 3 over, add it to both sides for both of these, and you get that x is equal to 2, and x is equal to 4. The next one we're going to look at is number 27. 27 tells you to solve by using the quadratic formula. This gives us 6x squared minus 7x is equal to 3. For this one, we have to move that 3 over first, so we're going to subtract it from both sides. This gives us 6x squared minus 7x minus 3 is equal to 0. Your A in this case is 6, B is negative 7, and C is negative 3. Remember, we said the other day when we went over the quadratic formula the first time that your equation is not going to be given to you. So you need to remember that your quadratic formula, bless you, is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now that you have your a, your b, and your c identified, plug them into your quadratic formula and just simplify. This is going to give you x is equal to the opposite of negative 7 plus or minus the square root of negative 7 squared minus 4 times 6 times negative 3 all over 2 times 6. The opposite of negative 7 is positive 7. That negative 7 squared is 49. The negative 4 times 6 times negative 3 gives us 72. And this is all over 12. We're going to add underneath that radical to give us x is equal to 7 plus or minus the square root of 121 all over 12. And then we're going to simplify from there. The square root of 121 is 11, so that's x is equal to 7 plus or minus 11 all over 12. Because that radical simplified, we are separating this and solving both fractions. So we're going to have x is equal to 7 minus 11 over 12, and x is equal to 7 plus 11 over 12. The 7 minus 11 gives us negative 4, and negative 4 over 12 is negative 1/3. So that's one of your solutions. The 7 plus 11 gives us 18, so that's 18 over 12. 6 goes into both, so that's 3 over 2. So two solutions for this one as well, the negative 1/3 and the 3 over 2. The next question we're going to look at is number 33. 33 asks you to use your discriminant to see or to determine the number of real solutions to each equation. For 33, it gives you 25x squared minus 20x plus 4 is equal to 0. This is in standard form, which means all of your terms are on the same side, and it's equal to 0. We identify our a, which is 25, b is negative 20, and c is 4. Our discriminant is just the part that's underneath the radical from our quadratic formula, which is that b squared minus 4 times a times c. Remember, when you use this, if you get a number that's greater than 0, you're going to have two real solutions. A number less than 0, it's two imaginary solutions. And a number that's equal to 0, so 0 is equal to 0, there's one real solution. So if we plug our values in, we're going to have negative 20 squared minus 4 times 25 times 4. The negative 20 squared is 400. The negative 4 times 25 is negative 100. Times 4 is negative 400. 400 minus 400 is 0. 0 is equal to 0. So that means that we have one real solution. I'm going to jump to a new page. For the next question that we're going to look at is number 43. 43 gives you 3x squared plus 2x plus 2 is equal to 0. It tells us to find the imaginary or the complex solutions to the quadratic equation. If you would like to try to factor this in order to solve, you could. If you don't want to and you just want to use your quadratic formula from the start, you can do that too. It's totally up to you. So this one, your A is 3, B is 2, and C is 2. So if we use the quadratic formula, which we said is the negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, this is going to give us the opposite of 2, plus or minus the square root of 2 squared minus 4 times 3 times 2 all over 2 times 3. The opposite of 2 is negative 2, which is what we have, so that's not going to change. Plus or minus the square root of 2 squared is 4. 4 times 3 is 12, times 2 is 24. So that's 4 minus 24 underneath that radical, and 2 times 3 in the denominator gives you 6. If we subtract in underneath your radical, we're going to have x is equal to negative 2 plus or minus the square root of negative 20 all over 6. That negative that's underneath the radical has to come out. In order to represent it, we turn it into a positive, we pull out that I. That 20 also factors to be 5 and 4, and that 4 is 2 and 2. So those two 2's pair up, and this gives you x is equal to negative 2 plus or minus 2i square root 5 all over 6. Now, you have to make sure that this is in simplest form. So look at the negative 2, the 2i, and the 6. So really, anything that's not underneath the radical. Do they share a common factor other than 1? They do. They're all divisible by 2. So this negative 2 becomes a negative 1. This 2i becomes a 1i. And this 6 becomes a 3. So that gives us an answer of negative 1 plus or minus I square root 5 all over 3. The next question we're going to look at is number 53. 53 gives you negative 3 and negative 6. It tells you to write a quadratic equation that has the given pair of solutions. So these are both x is equal to negative 3, x is equal to negative 6. So if we move the 3 and the 6 over to get x and that term by it or together, you're going to add the 3 to both sides to get x plus 3 is equal to 0. You're going to move the 6 over by adding it, and you get x plus 6 is equal to 0. From here, these are both equal to 0, so you can put them both in parentheses to give you x plus 3 times x plus 6, and then set that equal to 0. From here, just FOIL it out, combine like terms. So x times x is x squared, x times 6 is 6x, 3 times x is 3x, and 3 times 6 is 18. From here, combine your like terms. The 6x and the 3x give you 9x, so that's just x squared plus 9x plus 18 is equal to 0. Remember, with these two, they have to be set equal to 0. You're writing an equation, which means there has to be an equal sign in there, and it's going to be equal to 0. The last one that we're going to look at is number 55. 55 gives you negative 56. Let's look at 56. 56 is a little bit better. 56 gives you negative 2i square root 3 and positive 2i square root 3. For this one, again, they're both x is equal to. So move them over to where you have x plus 2i square root 3 is equal to 0, and x minus 2i square root 3 is equal to 0. We know that since these are both equal to 0, we do the same thing that we did with the one before this. Put them in parentheses, so you have x plus 2i square root 3 times x minus 2i square root 3 is equal to 0. This is what we call a difference of squares. Your first term is the same in both sets of parentheses. Your second term is the same in both sets of parentheses. They're just separated by opposite signs. So if you're not comfortable with using the difference of squares method, you don't have to use it. You can just FOIL it out, combine like terms. You'll get the same answer. If you are comfortable using it, you can just take that first term, square it, minus the second term, and square that. So that x squared is just x squared. The 2i square root 5 squared is the same thing as saying 2 squared, which is 4, I squared, which is I squared, and the square root of 5 squared, which is 5. So that I squared is also negative 1. So we're going to rewrite this to be x squared minus 4 times negative 1 times 5 is equal to 0. The 4 times -1 is positive 4, times 5 is positive 20. So that's x squared plus 20 is equal to 0. Again, if you FOILed it out instead, you would have gotten the same exact answer as long as you did your multiplication correctly. You simplified that I squared to be -1. Again, it would have been the same exact thing.